Hi dear viewers, welcome to my channel Science and Vigyan. Today we will discuss about Michaelis Menten and Lineweaver book plot. You can see on the screen two graphs are visible. In that we will discuss about the velocity. In the velocity, we have to, before going to the velocity, I will tell what about the substrate enzyme interaction. In that enzymes, like for example, if this is an enzyme, fine, and this is a substrate, fine. Okay, when this substrate they are binding to this enzyme, they make enzyme substrate complex. Fine, and this enzyme substrate complex they are lead to produce the velocity, and their expression is E joined with the S. It produce enzyme substrate complex. Fine, this is a irreversible reaction. This now just understand, no need to write down anything. After that I'll show you how the lecture is proceeding. You can note down the things. Fine, now just understand it, just listen me. This in substrate they are binding to this enzyme and it form enzyme substrate complex, and this is a reversible reaction because here forward and backward reaction they occur simultaneously. One is, this is K2, other is K1. Fine, this is a reversible reaction because when enzyme substrate they are making a complex, they also broken down as on the same other front. Fine, and they form the product. When we increase this enzyme concentration, it will lead to increase the velocity, because the velocity is, this is a V is velocity that is directly proportional to the enzyme. Fine. Because before going to the before understanding the enzyme behavior, we can't discuss their graph, we can't discuss their relationship between the enzyme and the substrate, and the substrate and velocity. Fine. Now you understand why this is increasing directly proportionally, because the relation is increase. Now you can see here velocity is, this is the velocity that is directly proportional to the substrate. Here also when we increase the concentration of substrate, velocity is increased, but it is saturated at a certain point. It is like this because when there is no enzyme but we increasing the substrate, velocity is not increase up to certain point, it is stopped. Fine, because enzyme substrate complex is directly related to the presence of enzyme and the substrate, not only the concentration of substrate. That is the reason it is like this. It is I think it is hyperbolic in nature. Fine. Okay, this is a key mechanism. This is just introduction. In the next slides, I will tell you about how you calculate this Km, what is Vmax, what is 1 by 2 Vmax, what is all about the velocity. Right, now I'll start the session. Now you can take your notebook and write down the thing. I can wait for you. Just come back and write down the things in detail. Now I just rub it. Okay. If anything that is not clear to you, you can drop a message in the comment box, or you can contact me through email, or I have one close group also on the Facebook, and on the Instagram you can follow me. You can send a message for any help. Next is, this is the same thing as I told you. It is hyperparabolic in nature. As I told you, it is hyperparabola. Rectangle hyperparabola is obtained when velocity is plotted against the substrate concentration. Now you know the reason why velocities increase. Fine, because up to certain point when we are increasing the substrate concentration, but enzymes are not available to make a complex with the substrate, so no more increase of velocity is done. Fine, that is the reason when we increase the enzyme concentration, velocity is increased, but when we increase the substrate concentration, velocity is not increased, it is saturated. Fine. Rectangle hyperparabola is obtained when velocity is plotted against substrate concentration. Fine. This is the velocity, and when it is Vmax, when this saturation is achieved, that is a velocity is maximum. Fine. When the velocity Vmax is half, at that moment, substrate concentration is equal to the mechanism. And we can prove it. Before proving it, you have to know about what is this mechanism. For that, you need to know what is the order of reaction. When velocity is, we know when velocity is directly proportional to substitution, in that the rate order is first order, and this is an enzyme kinetic. In the enzyme kinetic, we will learn about how enzyme they are combined with the substrate to produce unstable enzyme substrate complex that I told you. This is a K1, K2. Here I mentioned here K2. It's your wish. You can write down K1 or K2. It's totally dependent on you. It is just method to expressing the things here. Enzyme, they join with the substrate. They form enzyme substrate complex. After that, with the help of K3, they produce enzyme and product. Fine. Here we discuss about Km. What is Km? Km is the mechanism. This is the mechanism that is equal to K2 plus K3 divided by K1. Fine. And this is the mechanism equation where V equal to Vmax into S divided by Km plus S. This relationship you can obtain with the help of multilinear regression equation, that is Y equal to mx plus c. Fine. If you want to derive this equation from there, like I can tell you how you can write down y equal to mx plus c, or you can put the value of slope and the substrate concentration here. You can tell me. I can derive that also. But for this session, you have to remember this only. V equal to Vmax plus into S divided by Km plus S. Next is now, like in the maths, we have to assume. Here we assume when velocity is 1 by maximum, like earlier I told you, like when the velocity is 1 by 2 Vmax, in that moment, substrate concentration is equal to Km. Now we need to prove it. Find when velocity is 1 by 2 Vmax, at that moment, Km is equal to S. How we can obtain it? We have to put the value V is Vmax upon 2 and put the value here after rearranging this equation. If you want, I can do here also. Fine. If you want to do the all calculation live in the live session also, or in the next video also, please drop a message. I can do all the calculation in front of you. For this session, you can note down. After that, we have to cut this Vmax. So Km plus S equal to 2S. After that, S is come here. So 2S comes to the S. Km is equal to S. This we need to prove. K stand for a constant and M stand for a mechanism. Right? This we need to prove. Or this definition comes to be Km is defined as substrate concentration expressed in moles per liter to produce half maximum velocity in an enzyme catalyzed reaction. That is the Km. Okay. Next is half of the enzyme molecule are bound with the substrate molecule when substrate concentration is equal to Km value. This representing for the measurement of the strength of enzyme substrate complex. It means from the Km value we can tell either there is a strong affinity between the enzyme and substrate, or there is a weak affinity between the enzyme and substrate. Now come to low Km value. If the Km value is low, it indicates there is a strong affinity between the enzyme and substrate. If there is a high Km value, it means there is a weak affinity between the enzyme and the substrate. And generally it happens for majority of the enzyme, the Km value are in the range of 10 to the raised power minus 5 to 10 to the raised power minus 2 moles. Fine, because Km is not depend upon the concentration of enzyme. Fine. It also depends upon concentration of substrate. Got my point? Because here is a complex is made between the enzyme and the substrate, not only the enzyme. Okay, got it, I think. Okay, next is line Weaver-Burke plot double reciprocal model. Here we obtain a relationship between the 1 upon V and 1 upon S. Fine. When we write down Y equal to, here I can write down Y equal to mx plus c, mx plus c. Fine. Now fit this y equal to mx plus c into this graph. Here is 1 upon v is y and s is 1 upon s. Fine. Just put the value of this only. See this equation, not the first one. This is a y equal to mx plus c where m is slope. You can see this is the slope. Km divided by Vmax into x. X is 1 upon s plus c. And this is a constant value. That is 1 upon Vmax is a constant. Fine. See, this is the y equal to mx plus c. Now, trying to find out this relationship from the Michaelis-Menten equation. The equation is same one, guys. Only we just do the reciprocal of the earlier one. Earlier is v equal to v max into s divided by km plus s. We just divided with 1. That is a v equal to, here we write out 1 upon v and we obtain this relationship. Fine. This is the beauty of the chemistry. Things are very related to each other. Each thing is related to the next one. And we have a straight line graph is found between the 1 upon v and 1 upon s. Fine. No hyperparabolic graph. Done? As I told you earlier, the above equation is quite similar, equal to y equal to ax plus b. It's our wish. We can write down m also, we can write down a also, b also, any me. A plot of velocity versus the reciprocal of the substrate concentration gives a straight line, and the here slope would be km upon vmax, and whose y is 1 upon vmax. Like here they mention about when we change the velocity with the Vmax and the equation, that is expression changed to the 1 upon km. Double reciprocal model plot is very useful to understanding the effect of the various inhibitions. This is the graph as I discussed earlier also. This is all about the enzyme kinetic, enzyme behavior with the help of different plots. If you feel the videos are very useful, please share the lectures with your classmates also, with your friends also. If you have any problem with chemistry topic, with drug design topic, please feel free to contact me. Thank you so much. Stay blessed. Happy learning. And don't forget to subscribe and share the channel. Thank you.